Welcome to Chemistry Academy by Tanzil Sir, Fajandar Junior College, Wahur. Dear student, so far we have discussed some basic concept of chemical thermodynamics, process, type of process, state function, internal energy, enthalpy, first law of thermodynamics and first law of thermodynamics in different process. Now our next point is enthalpies of physical transformation. We know enthalpy means total heat content of the system. Enthalpy means total heat content of the system, or it is the sum of internal energy and pressure volume type of work, and we have written the formula H is equal to U plus PV. U is internal energy, P is pressure, V is volume. So enthalpy definition we have discussed. Now in this lecture we will discuss the enthalpies of physical transformation. In this point, our first concept is enthalpy of phase transition. Second one, enthalpy of atomic or molecular change. And third one, enthalpy of chemical change. Now, our first point, enthalpy of phase transition. Enthalpy of phase transition. Now phase transition means we can say one phase of the substance convert into another phase. Phase means solid, liquid and gases. So one phase of the substance convert into another phase at a constant temperature and pressure, that is called as a phase transition. And during this phase transition, the amount of enthalpy required or change in enthalpy, that concept we have to discuss. Now our first point, enthalpy of fusion. Student, fusion means we can say solid convert into liquid state. Melting of solid convert into liquid state. Now what is enthalpy of fusion? The enthalpy change that occur or enthalpy required. Enthalpy change that occur when 1 mole of a solid is converted into liquid without change in temperature at constant pressure is called enthalpy of fusion. What is enthalpy of fusion? Enthalpy required or enthalpy change that occur when 1 mole of a solid is converted into liquid without change in temperature at a constant pressure is called enthalpy of fusion. For example, water in solid state. Water in solid state means ice. That water absorb 6.01 kilojoule per mole of heat in the form of energy, and after absorbing this much amount of heat energy, that solid water convert into liquid, means one phase convert into another phase. This is called as the fusion. Now here we have seen without change in temperature, means temperature of the system remains constant. And why there will be no change in temperature? Because as the water absorb the heat, 6.01 kilojoule of heat, after absorbing this much amount of heat, water in solid state perform the work. And which work that solid has performed? So that solid convert into liquid state. Here temperature will not change, temperature will remain constant, because the amount of heat energy absorbed is utilized to do the work, to perform the work, and that's why there will be no change in temperature. It means this process is isothermal process. So let me clear, student, what is enthalpy of fusion. Enthalpy required or enthalpy change that occur when 1 mole of solid is converted into liquid without change in temperature at a constant pressure is called as enthalpy of fusion. Now fusion means solid convert into liquid state. Exactly opposite of fusion, we can say liquid back convert into solid state. What is opposite to fusion? Liquid back convert into solid state, and a reverse of fusion is freezing of solid. Reverse of fusion is freezing of solid. So this reverse reaction, it indicates the enthalpy of freezing. A reverse reaction means here we can say 1 mole of liquid convert into solid. Enthalpy change that occur when 1 mole of liquid convert into solid state without change in temperature at a constant pressure is called as enthalpy of freezing. So this enthalpy of fusion and enthalpy of freezing, these are the opposite process. In fusion, solid convert into liquid state, and in freezing, liquid convert into solid state. And student, important point, try to remember this process is isothermal process because there is no change in temperature. And why there is no change in temperature? Because the energy absorbed or evolved is required to perform the work. Here system performing the work, it convert from one phase to another phase, and that's why this is the example of isothermal process. Now, in case of phase transition, enthalpies of phase transition, our next concept is enthalpy of vaporization. Student, enthalpy we know. What is vaporization? Shan means process, a process in which vapors are formed. That is called as vaporization. So, in vaporization, liquid convert into gaseous state, means vapor state. In vaporization, liquid convert into gaseous state. So in short, we can say the enthalpy required to convert 1 mole of liquid into gaseous state, that is called as enthalpy of vaporization. In proper way, we can define the enthalpy change occurs or accompanying. Enthalpy change occur, take place, required, or accompanying the vaporization of 1 mole of liquid into gaseous state. Vaporization of 1 mole of liquid into gaseous state without change in its temperature at a constant pressure, this is called as enthalpy of vaporization. Now in this example, water in liquid state convert into water in vapor state. So water in liquid state absorb 40 kilojoule per mole of heat, and after absorbing the heat, this water liquid will convert into gaseous state, and this is the enthalpy of vaporization. Enthalpy, it is represented by H. Change in enthalpy, it is represented by delta H, and this VAP stands for vaporization. So this delta VAP, it is the enthalpy of vaporization. So after absorbing 40 kilojoule per mole of heat, that water liquid will convert into water vapors, means gaseous state, and this is called as enthalpy of vaporization. Now exactly opposite to vaporization. In vaporization, liquid convert into gaseous state. Exactly opposite means we can say the gas or vapors back convert into liquid state. The gas or vapors back convert into liquid state. This process is called as condensation. This process is called as condensation. So what is condensation? The vapors condensed or vapors convert into liquid state. That process is known as condensation. So we can define exactly opposite to enthalpy of vaporization. A concept is given, enthalpy of condensation. In condensation, the enthalpy change accompanying the formation of liquid. Yeah, condensation of vapors into liquid state without change in its temperature at a constant pressure, that is called as enthalpy of condensation. And here the enthalpy of condensation is minus 40 kilojoule per mole. So our first concept was enthalpy of fusion, and second one is here enthalpy of vaporization. Now next one is given enthalpy of sublimation. Enthalpy of sublimation. Now to sublimize means liquid convert into gaseous state. Now actually sublimize means solid convert into gaseous state. What is enthalpy of sublimation? Now sublimation means solid convert into gaseous state. Now how solid will convert into gaseous state? So first solid convert into liquid state, and then first solid convert into liquid state, and then liquid convert into vapor state. So that is solid convert into gaseous state, it is called as sublimation. So how to define the enthalpy of sublimation? So it is the enthalpy change required for conversion of 1 mole of solid, required for conversion of 1 mole of solid directly into vapor state at a constant temperature and pressure, that is called as enthalpy of sublimation. What is enthalpy of sublimation? The enthalpy change accompanying required occur take place for the conversion of 1 mole of solid directly into vapor state at constant temperature and pressure, that is called as enthalpy of sublimation. So sublimation means solid directly convert into gaseous state. So what is sublimation? Solid directly convert into vapor state or gaseous state, that is called as enthalpy of sublimation. So dear student, enthalpy of fusion, enthalpy of vaporization, enthalpy of sublimation, that is related to enthalpy of phase transition. Now fusion means we have discussed, vaporization we have discussed, and sublimation we have discussed. Now our next concept, enthalpy of atomic or molecular change. Our next concept is enthalpy of atomic or molecular change. Now our first point, enthalpy of ionization. Now here the word shun, shun means process, a process in which ions are formed, that is called as ionization. What is ionization? The process in which ions are formed. Now how ions will form? So the particular atom or molecule lost the electron, means there is a removal of electron. Lost the electron means there is a removal of electron. For example, in this case sodium metal in gaseous state, free means no charge is there. This sodium metal lost one electron. This sodium metal lost one electron. After losing one electron, that free Na metal convert into cations, means it acquired a positive charge. And why it convert into cation? Because it lost the electron, and cation and anions are the ions, and this process is known as ionization. So what is the enthalpy of ionization? The enthalpy required, enthalpy change take place, occurs, or the enthalpy change accompanying the removal of an electron. Enthalpy change accompanying the removal of an electron from 1 mole of gaseous atom, from 1 mole of gaseous atom, that is called as enthalpy of ionization. What is enthalpy of ionization? The enthalpy change accompanying the removal of an electron from 1 mole of gaseous atom, that is called as enthalpy of ionization. For example, Na convert into Na plus, and how Na will convert into Na plus? So that Na lost one electron and it convert into Na plus, and this is enthalpy of ionization. Now second concept, electron gain enthalpy. Electron gain enthalpy. Now in above example, we have studied formation of cations, means carries a positive charge, and how cation will form, carries a positive charge. How cation will form, so when it lost the electron. How cation will form, when it lost the electron. Now exactly opposite to cations, we will see here formation of anions. Anions means the species which carries a negative charge. Anions means the species which carries a negative charge. And how negative charge will develop, so when a gaseous atom molecules absorb the electron, there is a gain of electron. When it gaseous molecule atom absorb the electron, after getting the electron, its electronegativity will increase, and that free gaseous atom will convert into gaseous anions, means carries a negative charge. So what is the electron gain enthalpy? So the electron gain enthalpy on the other hand gives the enthalpy change. The enthalpy change when 1 mole of gas phase atoms of an element accept electron. When 1 mole of gas phase atoms of an element accept electron to form gaseous anion. To form gaseous anion, that is called as electron gain enthalpy. What is electron gain enthalpy? So the enthalpy change when 1 mole of gas phase atoms of an element accept electron to form gaseous anion, and it is represented by delta ion H, and electron gain enthalpy. So this one is your first enthalpy of ionization, and second one is your electron gain enthalpy. Now third point, enthalpy of atomization. Enthalpy of atomization. Now we know this point, shun means process. Now process in which atoms are formed, that is called as enthalpy of atomization. When molecules break, that molecule will convert into atom. See here, now Cl2 chlorine molecule, when this chlorine molecule dissociate, when this chlorine molecule break, this Cl2 convert into Cl atom. It will convert into Cl atom. So this is called as atomization. So how to define the enthalpy of atomization? The enthalpy change take place. Enthalpy change occur, or we can say accompanying the dissociation of 1 mole of gaseous substance. Enthalpy change accompanying the dissociation of 1 mole of gaseous substance into gaseous atom is the enthalpy of atomization. Now see, this one is your gaseous substance. When it dissociate, when it break, it will convert into atom Cl and Cl. So this is called as enthalpy of atomization. How to define enthalpy of atomization? The enthalpy change accompanying the dissociation of 1 mole of gaseous substance into gaseous atom is the enthalpy of atomization. Cl2 dissociate to form Cl plus Cl. Now second example, methane. The constituent particle of methanes are carbon and hydrogen. So when this methane break, it convert into carbon and hydrogen, 4H, or we can say, we can write here twice of H2O. 4H, or we can write here twice of H2O. Okay, now this is the enthalpy of atomization. Now next one is given enthalpy of solution. Students, we know how the solution will form, solute plus solvent. How the solution will form, solute plus solvent, like sugar and water. Sugar is the solute, water is the solvent. Okay, so that sugar dissolve into solvent water to form the solution. Now how to define the enthalpy of solution? Here I have quoted one example, our common salt NaCl. When it AQ means aqueous, aqua means water. When NaCl solid mix or dissolve in water, it will convert into aqueous NaCl, and it is called as the solution. And how to define the enthalpy of solution? The enthalpy change take place when 1 mole of substance is dissolved when 1 mole of substance is dissolved in definite amount of solvent, when 1 mole of substance or solute is dissolved in definite amount of solvent so as to form a solution of particular concentration, to form a solution of particular concentration at a given temperature is called enthalpy of solution. Student, how to define the enthalpy of solution? Enthalpy change accompanying occur take place when 1 mole of substance is dissolved in definite amount of solvent so as to form a solution of particular concentration at a given temperature. It is called as enthalpy of solution. Now here NaCl solid dissolve in aqu, aqua, water, it form aqueous NaCl, and the amount of heat, enthalpy required is 4 kilojoule per mole. So our first concept was enthalpy of ionization, second was enthalpy of atomization, third one enthalpy of solution, electron gain enthalpy. Now our next point, enthalpy of chemical change, a important and simple concept, enthalpy of chemical change. Now first one is enthalpy of chemical reaction. Enthalpy of chemical reaction. Now actually enthalpy of chemical reaction, it is the difference of, it is the difference between enthalpy of chemical reaction, it is the difference between enthalpy, sum of enthalpies of product and that of reactant. How to define the enthalpy of chemical reaction? It is the difference between sum of enthalpies of product and that of enthalpies of reactant at a constant pressure and definite temperature with every substance in a definite physical state, with every substance in a definite physical state, that is called as enthalpy of chemical reaction. And this delta RH, R means reaction, is equal to summation of enthalpies of product minus summation of enthalpies of reactant. And this point very important to solve the problem. So how to define the enthalpy of reaction? Enthalpy of chemical reaction is the difference between the sum of enthalpies of product and that of reactant at a constant pressure and definite temperature with every substance in a definite physical state. Now in case of enthalpies of chemical reaction, one concept is given, exothermic reaction and endothermic reaction. So already in 11th standard we have discussed what is exothermic reaction, the reaction in which heat is evolved. And what is endothermic reaction? The reaction in which heat is absorbed. So for exothermic reaction, delta H is negative, okay, and for endothermic reaction, delta H is positive. This concept already we have discussed. Delta H is positive means the reaction is endothermic reaction, and delta H negative, it means the reaction is exothermic reaction. Now next one is standard enthalpy of formation. Standard enthalpy of formation. Now enthalpy of formation means, in short we can say the enthalpy required to form 1 mole of substance from its constituent elements. What is enthalpy of formation? Enthalpy required to form, formation means to form 1 mole of substance from its constituent elements, like here formation of methane, CH4. Now in case of methane, the constituent elements means जिससे वो बना हुआ है, the constituent elements are carbon and hydrogen. Now the original state of carbon is C and hydrogen is H2, it is diatomic molecule. So when the carbon react with hydrogen gas, it convert into methane gas, and this is called as the formation. Now what is the standard enthalpy of formation? So the standard enthalpy of formation of compound is the enthalpy change that accompanies, take place, required a reaction in which 1 mole of pure compound in its standard state is formed from its elements in their standard state. What is standard enthalpy of formation? The enthalpy change that accompanies a reaction in which 1 mole of pure compound in its standard state is formed from its elements in their standard state. For example, the formation of 1 mole of methane in standard state. So methane will form when carbon react with hydrogen. So during the formation of 1 mole of methane, the enthalpy required is minus 78.4 kilojoule per mole, and this is called as delta F. F means formation, delta FH, that is enthalpy of formation. Now next one is given standard enthalpy of combustion. Now combustion means to burn. In 11th standard alkane topic, we have discussed when hydrocarbons are burned, oxidized, it will convert into carbon dioxide and water. Like here C2H2 means your alkene. Ethene gas when burn means react with oxygen gas. For burning, oxygen gas is used. So when it react with oxygen, it undergoes combustion to form carbon dioxide and water. So how to define the enthalpy of combustion? So the enthalpy required to burn 1 mole of substance. Enthalpy required to burn, to combust 1 mole of substance in its standard state is called as enthalpy of combustion. To burn, or we can say to oxidize, to burn or to oxidize. So how to define standard enthalpy of combustion? Standard enthalpy of combustion of substance is the enthalpy change accompanying a reaction in which 1 mole of substance in its standard state is completely oxidized. 1 mole of substance in its standard state, 1 mole of substance in its standard state is completely oxidized. That is called as enthalpy of combustion. Now in case of the enthalpies of phase transition, our last concept is given bond enthalpy. Bond enthalpy, or we can say the bond dissociation energy. Actually the bond dissociation energy, in short we can say the energy required to break a particular covalent bond. What is bond dissociation energy? Energy required to break, enthalpy required to break a particular covalent bond is called as bond enthalpy or bond dissociation energy. See this example, H2 diatomic molecule in gaseous state. When it dissociate, when it break, it convert into H plus H. So how, and the enthalpy required is 436.4 kilojoule. So how to define the bond enthalpy? The enthalpy change required to break a particular covalent bond in 1 mole of gaseous molecule to produce a gaseous atoms and or a radical ions. Gaseous atoms or radical is called as bond enthalpy. Energy, enthalpy change required to break particular covalent bond in 1 mole of gaseous molecule to produce a gaseous atom or radical is called as bond enthalpy, or it is called as bond dissociation energy. Some examples are given here. So student, this is all about enthalpies of phase transition.